So we've got the problem before us is a mass of some weight going down a snowy slope for a set distance, and we're going to try and sort of work through and explore the numbers that are involved with this. So the first thing that we do with any problem like that is we look for sketching a free body diagram. So I'm going to pause this and sketch out a diagram for you, and then we'll start doing some of the maths. So here's a diagram, and we've got 32 kilograms. That's the mass of Percy on my blog. And the first thing that we need to think about is the force acting due to gravity, mg. Okay, so if we start thinking about gravity is acting downwards, but also we've got what's called the normal force. That's the force acting in this direction as perpendicular, so 90 degrees to the slope, like so. And you sometimes refer to this as the reaction force or the normal force. We're going to label that Fn, because I like to think of it as the normal force, the reaction force, and the slope angle is 25 degrees, which means that this angle is also 25 degrees. And the force that we're interested in is this force acting in this direction across here, which actually would be acting on Percy in that direction. So what is that force? But there's also going to be a coefficient of friction. So there's going to be a friction force. So we're going to label that FF, friction force. We're going to call this the slide force. We're going to call force for sliding. Okay. And there's also going to be a second negative, if you will, which is going to be the force due to drag. So we're going to label that FD. So we've labelled all our forces: the mass due to gravity, the normal force in reaction to the slope, 90 degrees, or 25 degree angle here and here, the friction force, the drag force, and obviously the sliding force that's acting downwards. So let's look at this sliding force. I'm going to look at the sliding force as being, now the first thing to do is work out this force. Now this is the opposite of this triangle. It's a right angle triangle, and this is the opposite. So we look to SOHCAHTOA, sine of the opposite times the hypotenuse will give us this force. So we have mg sine 25 degrees gives us this sliding force downwards. We'll need to take away from that the friction force. Now I've looked it up, and the coefficient of friction, CF if you will, is for wet snow on a sledge is about 1.4. Okay, so it will be the coefficient of friction, and it's this force here, it's this normal force. Now this is the adjacent, so this is the cosine. So it's mu mg cosine 25 degrees. And then on top of that we need to take away the force due to friction, force due to friction of air, or the drag force, which I'm going to put FD here because that is quite a complicated formula, and I'm going to have a look at that a little bit later on. So we've got, let's put a calculator in, we've got a mass of 32 kilograms times 9.81 for gravity. It's going to be 313.92. I'm going to make a little note of that because it's a little bit handy later on. So mg 313.92. Okay, we won't start doing any rounding up yet, we'll do that near the end, because the sooner you round up, the more additional errors you can bind into your working out as you go along. So 313.92, we need the sine of 25. So sine, 25, so I'm using an old calculator here, is 0.4 times 313.92 equals, so the downward force, this force due to the sliding, would be 132.666. We'll round up to 67, go to 2 decimal places. I need to take away from that, I have 0.14 times 13.92 times the cosine of 25, so 25 cosine 0.9, round that up to 1, 2 decimal places. So that's going to look like this, 0.14 times 313.92 times 0.91 equals 39.99. So the drag force going in that direction, if you will, that's going in that direction, and then we would need to take away the force due to drag. Now, well, there's Percy getting excited about sledging again. Force due to drag is the coefficient of drag. Now this is a unitless number, and it's a bit like coefficient of friction. It's a numerical value that you can only establish through observation and experimentation. It can't be calculated. The A is the cross-sectional area, so we'll have to measure the cross-sectional area of the dog, because that will be how much air resistance or wind resistance we've got. And this will give us a value that, again, it's the wind resistance, so as it's sliding down, the air will be pushing back. I've checked the coefficient of drag for an upright person, and this is very similar, is 1.3. So we're going to end up with 1.3 here times the rho density of air, 1.225 kilograms per meter cubed, times the velocity, which is worked out to 17.44 meters per second minus 1. Divide that by 2 and multiply it by the cross-sectional area of the dog, which is, worked out to about 0.0, so we'll call it 0.1, round it up because he's got big floppy ears and they had a bit of extra drag. So the drag is going to be, put this for a second, 1.3 times 1.225 times 17.44. This needs to be squared. Always worth checking. 17.44 squared is, so that's going to be 304 in there. Let's try again then. 1.225 times 304.2 equals that. Divide by the 2 times 1.3 times 0.01. So we've got a drag factor of 24.22 newtons in that direction. So if we put that in here, we've got 132.67 minus 39.44 minus 24.22 newtons, which will give us a our downward force. So 132.67 minus 39.99 minus 24.22 equals a resultant of 68.46 newtons in that direction. If we divide that by the 32 kilograms, that should give us force is equal to mass times acceleration divided by 32 for an acceleration of about 2.14 meters per second per second. So if we take that figure and we think about our suvat, v squared equals u squared plus 2as. Well, we're trying to find that. We know that's going to be 0. We've got that as 2.14. We know what the distance is. It's 43 meters. So if we rearrange, v will be equal to the square root of 2 times the acceleration, 2 times 2.14 minus 2 times 43 meters, which will equal 2 times 2.14 times 43 equals square root of which is, so the velocity at the bottom of the slope will be 13.57 meters per second minus 1. Now if we times that by 3600 and then divide by 1000, divide by 1.6, this will give us it in miles per hour. So divide by 1000, divide by 1.61. So it's roughly 30 miles per hour down the slope. So if you take that information, you can carry out a similar activity on the figures that you were given in your problem, and you should be able to calculate how many miles per hour you personally or your other calculation for any distance, for any angle of slope, you can work out what sort of speeds you'd be able to get. You might need to look up the drag coefficient for things like snowboards, etc. They're slightly less drag coefficient due to the snowboard being a different material, but you will find that your cross-sectional area and wind resistance will be slightly changed. You have to think about whether you're going flat forward, sat down, or whether you're stood up and on your side, because of course that cross-sectional area will change and affect your calculations. And I hope you enjoy the snow.